Hello everyone and welcome to this video tutorial. Here I'll be teaching you my approach on cracking and reverse engineering application number 10 from Lucid Dream. This is version number 2 out of it's version number 1 Crack Me. It's fairly pretty similar to the previous one. If you actually look at the previous one, let's take a look at it real quick and let's just make a quick refresher. And yep. So yeah, this is the um, encryption algorithm for this string that we input. Anyway, it's the same. It's almost the same thing with the application number 10. It's just a little bit harder. Um, in the previous Crack Me, you could input your name and you can input the code, and from there you could see what was your name getting coded into, and that was the code for it. All right, but then in this one, in Crack Me number 2, you only have like one text box to input something, and you hit OK or you hit Go, and it tells you this error message. Sorry, you got it wrong. Try again. Alright. So the thing is that um, those are the similarities and those are the differences. Um, Now let's go straight ahead into cracking the program, the application. Alright, just like the same, let's just take the same approach as we did in the previous video. If you haven't watched, and I cannot stress this anymore, please watch the video number 9, because if you start watching this one, I won't be explaining things that I already explained on video 9. I mean on the Crack Me number 9 that I did already. So you may feel kind of lost on this one. I do require I haven't been actually mentioning this, but I do require some that some viewers might need some knowledge already. All right, so that's why I'm not actually saying this like every time in the videos, but I pretend that the viewers that are watching this video already has some previous knowledge on reverse engineering, so they will be they will be able to follow along, and you know how it is. You know how it is. Okay, so the thing is that let's jump right into it. And some of the things that we're gonna look at are string references. Of course, we're always gonna look at the string references. And out of all them out of all the 11 strings are over here, we see one that it's especially it's kind of caught my attention. Specifically this one over here. Sorry. Um, I have to edit. Oh. It's especially this one over here. It is oh, it is on address 4037E, and if you look at it, it's like a code or a password or something, but it's encoded. How do you know it's encoded? Because because when you take this and try to convert it, it gives you this ASCII. It will look like it is already encoded. So the thing that we're going to do is we need to understand what this string over here is, what this encoded string is. Alright, so for that we're going to run the program, type something, and that was literally something I just made up. And let's start analyzing what's going on here. And you will see that it's the same approach with the previous one. Intermodular calls. Here we have the get window text A, and then just below we have a call to a function. This is where we're actually at right now. Okay, so it only changed that we're now getting into a call, getting into a function, not directly through the code. Alright, so the thing is that we keep doing this. It is basically the same thing. It takes the first 4 letters, XORs them, pushes CVX, takes the next 4 letters, and then it XORs them, stores them in. I will show you here. Stores them in these space in address memory, and then takes the other one and stores it as well there. And it pops EBX. Pop EBX, what it means is that it takes the topmost value from the stack and pops it onto the register that it's stated over here. In this case, it takes the topmost value from the stack and put it into EBX. EBX is over here, so you will see that it will move onto there. All right. And alright, so let's keep on it. Now it pushes EDI onto the stack, which is the address, and then it moves 10 onto EDI, which is actually 4031 48. It's gonna move it onto EDI, and then it's gonna shift logical write EX 28 times, which if you wanna double check that, 28. 1C, I'm sorry, what I'm doing. So 1C is 28, so as you can see. And then we're left with 6. Then it's comparing AL, which is 06, comparing to 0. It is not 0, so it's not gonna jump. It's comparing to 9. It's not 9, so it's not gonna jump. But now it's adding 30 to it, so it's gonna be 36. It jumps over this add. It doesn't take it, and now it's moving AL into EDI, and I will show you what EDI is. EDI is right over here in 4031 for A. Which is, yeah, it's storing AL, which is it's gonna store 36 right in the space of memory. You see that it's stored it already. Now it's taking the value of the D word value, which is, and it's not taking a byte. If it would say a byte over here, it will take a byte only, but it's taking a whole D word pointer from 4031 5B, which is this over here, and this is little endian. So when it's get passed over to the register on EAX, it's going to be 6038 F7 D9. All right. So let's continue that with that instruction. As you can see, it took the value 6038 F7 D9, and it sent it to EAX. It's gonna shift left EAX 4 times, and we're left with 030AF7D90, and then it's going to shift EAX 18 times again, so we're left with 03AF7D90 with a bunch of zeros. Alright, it's gonna compare AL to 0, and it's gonna take a jump. It's not gonna take a jump because AL wasn't 0 at the time. It's gonna compare AL to 9. AL is 0, so it's gonna jump. It's gonna add 30, so we have 30 there. It's gonna jump over this add. It's gonna do the same thing all over again. All right, I don't want to extend myself too much into this. I just keep going, running through it, tracing, I should say. Skip tracing, and once it finishes, as you can see, here it's where it finalizes moving AL until EDI plus 10. EDI plus 10, which AL right now is 0, so it's not gonna do anything at all. It's gonna pop topmost value from the stack onto EDI, and it got pops ESI, push EBP, and this is an epilogue from another function. I'm guessing this has to do with the way that Microsoft works in this specific application. It did some Windows things over here that I'm not really sure. Yeah, like end painting, delete. All right, let's keep on our thing here. So it pushes ESI. Oh, okay. So it pushes ESI, push EDI, and push ECX onto the stack. ESI, EDI, ECX, and now it moves whatever is stored on 4037E, moves it onto ESI. As you can see, ESI got updated already, and then it takes whatever is stored on 4031 4A, which is over here, and stores it on EDI, moves it onto EDI. Alright, so now what it just does is this means repeat compares strings from EDI to ESI. So yeah, wait, yeah, here it moved a 10 to ECX, and as you can see, it did this operation already. Compared and 0. Compare ECX against 0, and ECX is not zeros, it's C, so it's gonna take the jump. Alright, this is our jump to our wrong password thing target. Okay, so one thing that we know already is the algorithm that it's taking in order to encrypt our string, and it will look like it's taking taking these the string that we input, and it's like hard code comparing it to the one that is already on here. So 6032, and I'm gonna copy that real quick. Alright, sorry for the alright, so this is a string that is hard coded on the application, And this is our string that we just got. Following down PDI, okay. Or edit. So we could say that there's some familiarities and some similarity, I should say, some differences. For example, the first character is the same as the one that is, for example, the first character of my password, my encoded password, it is the same as the one that is hard coded. But again, then we have a change over here. I have a 38 in hexadecimal. 38 in hexadecimal is oops, is 8. And here what it has is a 32. 32. Okay. Then I have a F7, and here it's asking for an F9. Then I have a D9, and it is asking here for a CE. So let's try to debug or reverse or analyze this a little bit further. What's going on here? So first, we'll see that. Let's take the key that it's already the keys that is taking the encryption from the XOR, I should say. This is the first key, the first XOR value, and the second XOR value. All right. All right. So here we have this now. What happens if I XOR this against this? Let's try and play around with the XORs. So we have this result, and let's see if we put it on input 1. It is going to give us the first key. All right, and now let's see this one and this one. Yeah, so it takes yeah. So if you see the pattern already, this is like a pattern. If you take a block, I mean, and I call this a block. I put it like a symbolism to better understand it for myself. So if you see the first block and you compare it against the other block, you will have this like this decrypted key. But if you use this key to, for example, encrypt the first one, you will end up with the second one actually. And if you take the second one and encrypt it with so the first one, you will have EDB. As you can see, it gives you the first one. You see, it's kind of like a puzzle, like a crossing puzzle thing pattern that is going on. So what if you take your encrypted, or the string that you input, and you take it and you XOR it against the this over here. It's going to give you this, and the result and will be your decrypted password, the thing that you put in there. All right. So now we are understanding how this is going, where this is going, and how we can tackle this particular algorithm. So in this case, now we are left with understanding now that we can crack the password that is hard-coded. So in this case, if we would like to crack the password that's hard-coded, we will just have to do the same thing that we did with our encrypted string. Alright? So for example, let's take the first block of our encrypted string, just like we did, and we input it here in the XOR calculator. And then we take the first block of the XOR key, and then we XORed it. And then it gave us, the result was the plain text password that we just inputted. Alright, with that in mind, then we can do this. We can simply take the one that is already encoded. We can do the same thing. Encrypt it again against and XOR it against this one over here, which is the same. And as you can see, it gave us the plain text password, at least the first 4 letters. So if you want to do it, just do it with the remaining. Let's delete this one. This is our password. Let's take this one, and since it's the last, this is the other block of code, then we're gonna use this block of code, which is the other XOR key. And what we are left with is etly. So we could say that the password is etly secretly, and that is a password. There's nothing else to it. There's nothing else to it. If you wanna look at it, let me delete all the breakpoints. Let's run it again, and let's put secretly over here. I hit go, and as you can see, the password matches in memory because they are the same now. Remember that this is like an encoding thing. So the first value that we put, it was slightly different when it was encoded. But now the one that we have, since it matches this one, which is in the one in memory, this is the password. So it tells you that the password for HBH is secretly. It's actually giving you the password itself. It's like you cracked the password itself. So we did it. Alright. We finally did it. And well, that was everything. Thank you for watching. Here we are at the conclusion of the video tutorial. Only 23 minutes. I wish that I could be a little bit more how do I say that, efficient on the time, but where I want to take my time, really teach people, the benefits of analyzing and doing all this stuff and all the thinking, all the that requires to have a nice and a good reverse engineering. And by no means, I am by no means like a awesome professional reverse engineer, and not even close to that. But so far, I like very much the ambient of reverse engineering here. Alright, so the thing is that this will be the conclusion. This will be the ending of the video. Thank you for watching and have a great day. Hope you have learned something, and stay tuned for the other applications that I will be posting up here soon. Alright, thank you for watching again. Bye bye.